Oakley dokley. How's it going, everyone? Welcome to the stream. I hope everybody is doing well. Apotham, you are indeed first tonight. How's it going? It's good to see you. RCW, good to see you as well. I'm Gelling, welcome. Ruche, welcome. So I hope everybody's doing well tonight. We are going to continue on our animation system tonight. We're going to continue hooking things up, getting things sort of laid out, and hopefully make a reasonable dent in the progress tonight. We're also going to sort of combine some of the other concepts that we had in some of the other systems that we were thinking about. We're going to combine those all into a single system, which we kind of discussed in the last stream. But before we get into that, I do want to just take a quick second and thank the supporters of the channel, beginning with the elite partner Javier Lazaron, followed by the partners Gerbolis Inc., Matt Osgard, and Magetsub. They are the highest tiers of subscription over on YouTube memberships, Patreon, as well as Twitch subscriptions. I'd also like to thank all the other folks you see here listed on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It is greatly appreciated and helps me cover the costs associated with running this channel. Things like software licenses, hosting fees, things of that nature. So thank you all for that. It is greatly appreciated. And of course, I would like to extend a large thank you to all of you, the viewers, whether you're joining me here live on the Twitch side or the YouTube side. We do simulcast rather to both. Or if you're just catching the VOD after the fact, thank you very much for being here. Without you guys, this project would not exist. So thank you all very much for being here. I appreciate each and every one of you. All right. So in the last stream, we were sort of leaving ourselves some to-dos here of some items we need to address. But I wanted to take just a quick second, because I never did get a chance to do this in the previous stream, and just sort of take a look at some of the code that I had come up with off stream in terms of how our animations are actually going to work. So we did kind of review the structure of the way that all of the data is sort of contained, right? So we've got our animated mesh assets. We have an animator that's responsible for playing a particular animation against that asset, and then also sort of maintaining a state of that at the same time. And so we've got a bunch of functions here to support that. And so essentially we have just a bunch of utility functions in here. I don't think we're going to need these things outside of this particular file, so I've chosen to make them static for now. So it's things like getting a particular node's index, or finding the index of a bone, things like that. We have the interpolation of positions, rotations, and scales. And so essentially that's just going through and interpolating those various bits of the transform against the given time for that particular channel, right? So we've got that, and then we have basically the thing that ties all of that together, which is this internal sort of process animator. And so this is the function that essentially kicks everything off and does the major lifting of the entire system. So the way that this works is it takes in a particular animator. It takes in a particular animation, which we might wind up actually changing. We'll have to see about that. And then it also takes a node index and a parent transform. So this is designed to be a recursive function. And the way that this works is it essentially walks down the skeleton, which is essentially a hierarchy of nodes, and does all of the interpolation for the current animation, calculates all those things, and then stores the matrices. So we've got the asset here. We take convenience pointers to the asset in the node. We take the node's transform itself, and then we go ahead and we grab the channel. And then here's where we interpolate the translation, rotation, and scale for that particular channel. And then ultimately, we create a transform based off of that. We then calculate the world transform. So that is just basically the node transform times the parent transform. And then we go ahead and we combine that. So this essentially is the base transform of the node, right? And we combine that with the bones, right? So we say, let's get the particular bone that we need for this particular name. And we go ahead and compute what we call the final matrix, right? Which is the essentially taking the global inverse transform, which is something that's given to us at the model level, and multiplying that by the world transform, and then multiplying that again by the bones offset transform. And so we take that final result and we store it in final bone matrices. So this animator final bone matrices, this is what winds up going into the storage buffer. And so we'll wind up, going ahead and uploading that at some point, probably all in one shot for all animators across the board. From there, we then recurse children simply by going through the node's children and calling process animator against that particular child, using the world transform as the parent transform. And that is basically the way that this works, right? And so that gives us all the transforms that we need. We still need to load the mesh data and all of that to the GPU, but at least at this point, it's ready to essentially go to the storage buffer. All right, Singy, good to see you. Welcome. Hope you're doing well. Let me see. MDS Ubuntu with a 3-stream watch streak. Appreciate that. Welcome. Hope you're doing all right. Orshi, good to see you as well. Project ZRO, good to see you. Welcome. Okay. So this process animator is basically going to be the main thing that we're going to call from our update loop. So that's essentially what we're gonna be doing. We're gonna be looping through all of that. However, we can't do that yet because we don't actually have anything stood up or sort of instantiated. None of our instance stuff is set up. So we're gonna need all of that stuff to be set up to get the data that this function actually needs. Couple of other things in here. We do have just a convenience function to create an animator. So again, just bear in mind that the animator is sort of the instance level state for an animation, or an animated mesh rather. And then we also have the ability to set an animation. This may wind up not being a function at some point, because there's not a whole heck of a lot that it does. It essentially sets current animation and then resets the time to 0. So we might wind up removing a few of these functions and just sort of doing them in line, but I kind of wanted to just put them there while we're sort of still feeling this whole system out. Okay, so there's that. Then we also have animator update. So animator update is what calls process animator, right? So this is essentially what handles the time for us. So it sets the time and ticks on the animator, and then goes ahead and updates that, looping it where necessary. And then we go ahead and we kick off the process of or processing of the hierarchy, right? So we do that. And then this essentially will be, I think, what we'll wind up calling from the update function, right? So there may be opportunities for us to sort of simplify this, but this is kind of what I laid out initially, just kind of trying to sort of set up a brute force way of doing it before we ultimately refine it. Okay. Animator get bone transforms. So this is essentially just something that takes all of the transforms and packs it into a mat4 array that we pass here. I'm not convinced I'm going to keep this one, but it was just one of the things that I needed to think about in terms of how we're going to handle these final bone matrices being uploaded to the SSBO. So there's that. I think we can probably do some sort of inline function for this, or maybe not even a function at all. Maybe we can just handle this within the update loop itself. I haven't fully decided on that. Or I'm sorry, it shouldn't be, I guess it shouldn't be the update loop itself that would get this. It would be technically it would be the frame prepare, right? Which is where we'd want to do all of the uploading to the SSBO. Okay, so we have our mesh system initialize. So that already sets up our base mesh and instance arrays. So now all we have to do is actually go through and handle the acquisition of a particular mesh instance. So acquisition of a mesh instance needs to do a few things. It needs to first obtain a unique ID for lookup into the resource arrays, right? From there, it will need to I guess let's create ourselves a little list here in line, right? So from there, it's going to have to do a couple things. It's going to have to request the animated mesh assets, and this is going to be asynchronous, right? Which means when done, it'll have to call or make a callback or invoke a callback. Invoke callback to upload to GPU, etc. Right? We should say upload mesh verts indices to GPU, right? We'll also have to, I guess, at the end of this, also request material instances. Okay, so we'll need to do that. And then that's, I guess, return a K animated mesh. Oops. Keep hitting the wrong keys here. Should be a K animated mesh instance containing the indices into both base and instance arrays. One caveat to this is, well, I guess it's not really a caveat, right? Well, I guess we can kind of go through the same type of, let me think about this. So we should probably check first to see if an animated mesh asset with that name exists and is loaded. Well, actually just exists, right? If not, then we do that, right? If it exists, just return K animated mesh instance, right? Okay. So we have that, and then this is essentially going to be the same as above, but specify package. And probably actually what we'll do in fact, I'm going to move this down here. We're going to have one call the other, right? So we're going to do return k animated mesh instance acquire from package. We're going to do state asset name. Package name is going to be state default application package name. And then we'll pass in callback and context, right? So one is really just, this one's really just a convenience function. This is the one that's going to do all the sort of heavy lifting. And so ultimately, that's the way that that's going to work. And then release is going to essentially undo a lot of this this stuff here. So this is essentially what we're going to be stepping through tonight is sort of setting up this bit here. And then as we need to, we'll go ahead and also set up the, we'll move over the SSBO and all that other stuff. Let's see. Is there any hardware you need or software to make your job easier or more efficient? That is sort of a preference thing, right? So I do have stuff that I use that makes it more efficient for me, but what works for me might not necessarily work for you. So the software that I use, obviously I use NeoVim to program in. I've been using this for a few years now, and I'm more efficient with it than your standard editors. So for me, that's definitely a better thing. I use Linux because I find that faster to develop in. Again, go with what tools you know. In terms of hardware, I do have, let's see, I think I actually put it in the Twitch, about information below the stream as to what keyboard I use. That does make a little bit of a difference for me. I actually have the Keychron Q11 split keyboard, which is, let me pull it up. Which is this one. It's not a cheap keyboard, but there's a reason I have it. So this allows me to place it at a ergonomic angle that works best for my hands on the desk. And the fact that they're not connected together directly is much better for how I type, right? And the reason for that is I have issues with carpal tunnel. And so I probably should have switched to something like this way, way long ago. But I didn't, and I learned that the hard way. So keyboard is important. If you're going to be doing a lot of programming, keyboard is important. Something that is easy to type on, is easy on your hands, that doesn't require a lot of effort to push the keys, is going to be better, right? Your typical keyboards that come with a lot of desktops, pre-built desktops and stuff like that, your cheap keyboards generally are not very good ergonomically, and they will cause problems after a while. So I recommend, a high quality mechanical keyboard. Save for it. I certainly did. And definitely, it's an investment. But your hands will thank you in your future. I actually have to go for carpal tunnel surgery in November because I didn't pay enough attention to that over the years. So I've made adjustments now, but that's the biggest thing I can say in terms of equipment is get the right keyboard. Especially if you're going to be doing lots of programming. So that's not as much about efficiency. I know your question wasn't as much about that, but it is something I try to drive home quite often. I hope that makes sense. Let's see. Other things as far as efficiency. I don't know. I mean, I've just kind of gotten used to what works for me. A lot of people will tell you out there oh, this tool is the best and it's the only one you should use. And that's not necessarily always the case, right? I always joke on here about, using VS. it's a family friendly stream, so I don't say that word, right? But like, it's let me see. I don't even have it open. So, I joke about this all the time, but it's literally just a joke, right? Like, if this is what you're more comfortable with, use it, right? NeoVim is great for me. There's a steep learning curve with it, but use the tools that you're familiar with and the fastest with. If you want to learn something different and you want to maybe explore something like this, have at it, but definitely keep that in mind. Want a split keyboard, but justifying a $200 keyboard is not easy to do. Yeah, I hear you totally on that. And I struggled with it for a long time, but like I said, I'm actually to the point where I have to go for surgery, because this hand right here is painful about 60% of the time and numb about 30% of the time. And so, it's to a point I actually have to go have surgery to have it fixed. So the only reason I'm bringing that up is it is an investment in yourself. And it's something that I kind of wish I had done, because then I might have been able to avoid surgery. Yeah, if you could for a living, it's an investment, not a luxury. Yeah, that's well worded. Yeah, that's basically what I'm trying to say. And I don't think. Let me see if I can actually. Let me see if I can show you what this keyboard looks like. So right there is how I have it set up, right? So the angle of my typing is natural. I'm not like kinking my wrists. Like if I put this together, right? The angle, if you look at the angle right here of your wrist, that's terrible for you to do, right? Even in the proper typing position. Whereas I can go like this and split them apart to where it's comfortable for me to sit and my wrists are straight all the time, right? That has made a huge difference in terms of comfort and not having as much pain when typing. Is it the same kind of surgery pro bike riders get to reduce pain in their forearms? I don't know which one that is, so I can't tell you, unfortunately. Hate that has to be the case for you. I worked in a hospital clinical side, so I'm in many cases of it, hoping for the best outcome. Yeah, so I think they're going to do it laparoscopically. They claim that I'm only going to be out of commission for like a day, right? But I'm also going to have like I'm going to have to wear a brace for 10 days that I cannot take off under any circumstances. And then I'm going to have 6 weeks of recovery time where I can't lift or pull or push anything with this entire arm over 5 pounds. So yeah. It's funny you bring up a trackball mouse. I don't know if you saw mine, but I actually have a trackball mouse as well. And it keeps me from having to move my hand all around too. I switched to one of those as well, and that was well worth it. So yeah, I mean, the thing that I can stress the most is, even more so than efficiency, get stuff that is comfortable. If you're going to be doing this as a career, as soon as you're able to, make the investment in good hardware, because even since I've had this keyboard now for maybe 6 months, and it's made a monumental difference in how my hands feel. It's not anywhere near as painful to type, and I wish I'd switched to it years before. So yeah, that's something I wish I'd done sooner for sure. Keep my wrist straight but type at an angle. Yeah, so I mean, like, generally speaking, you want this to not have to not have to move, right? You want to keep it as you don't want to be doing this number, right? You want to keep it straight as possible. And you also don't want to have to do like this with your elbows, right? Just to make your typing position correct, so to speak, right? Because your arms don't do this in a straight line naturally, right? They're more like this. You're looking at a split one. You're on the Microsoft Ergo right now, but it's so big. I had an old version of the Microsoft split keyboard, and I hated it. I absolutely hated it. Mostly because it's at a fixed angle. So you can't adjust it, which I don't know if you noticed, like on mine, it's not 100% symmetrical because it's a little bit like my right hand prefers a little bit different of an angle than my left hand. By angle, you mean your right fingers are on BKL and pinky floats. I gotcha. Okay. BKL. BKL. Okay. I'm trying to envision how that actually works in my head, and I'm not getting it. Let's see. Maybe this is your next step up. What's this one? So you're recommending this guy. I mean, maybe minus the pink, right? Let's switch to a less obnoxious color. I don't know that I would like that, actually. Because the thing I like about this keyboard is the keys are in a standard position, right? Whereas that one, the position changes. So the one thing that I was looking for when I researched this particular keyboard is I didn't want to get so used to typing on this that I couldn't type on like a laptop keyboard or something else without a lot of pain of like mentally having to switch back. I wanted something that still felt the same, but if I had to switch to a laptop keyboard, which I do have to do on occasion, it wouldn't be too difficult of a thing. But yeah. Used to use Emacs back in the day, and that editor was the worst thing for wrist and finger pain. Yeah, the keyboard shortcuts for Emacs are terrible. I used it for a couple of weeks when I was trying it out when I was trying to decide between Vim and it, and that was the killer for me. Yes, I know there's evil mode, but still. Yeah, that definitely was like, whoever thought that was a good idea was just not thinking it through. Just imagine you're a 17-year-old and then you tear a bunch of stuff in your left wrist. Then to keep gaming, you start holding the keyboard like a guitar, then never corrected. I'm literally trying to picture that, but okay. I mean, but again, that sort of goes back to like use whatever's comfortable for you, right? So yeah, like the split keyboard's great for me. The thing I like about it is it's not necessarily, I mean, it's kind of closer to a one size fits all than as you could get, I think. It's not a rigid layout that you're kind of stuck with. But yeah, you got to use whatever's most comfortable for you, but just make sure that it's ergonomic and that you're not contorting your wrists in weird angles. That's the biggest thing. Do you like the stacked monitors too? Yeah, so I have a couple of my monitors are a little bit older, right? I've got two 4K monitors in the center that I upgraded like 2 years ago. And then I've got two 1080p monitors that are vertical this way. So I usually use those for like Discord and or when I'm streaming, I have the chat windows open on that. Seems like a good idea for neck relief. Yeah. So usually this one, like the one that I work on for stream, is basically at eye level and a little bit below. And then the one that's right above where I drag this window down from is just above eye level, but I don't have to like crank my head way back to look at it. I can just kind of glance up a little bit. So yeah, I mean, the other good thing about that is like if I notice that the position gets weird, I could just switch it to the above monitor and just code in that position for a bit, and that helps. "33 now, software engineer, no issues on a standard layout." I do that though. Yeah, fair enough. Yeah, so I didn't really start having issues. I've actually been putting this off for a while, getting the surgery. I've been having issues with this arm for 2 or 3 years now, and I just turned 40. So take that as you will, but you're at 33. I started having issues around 37. It's probably time to start thinking about being ergonomic. Yeah. You're not too far off. So you might want to start thinking about it for sure. What's your desktop environment? Was that easy to set up for? So I use KDE right now, Plasma. That's Wayland now, and it was actually really easy. So yeah, worked out really well. Before this, I was using Cinnamon for a long time on X11, and that worked great, but this allowed me to switch to Wayland, which is way nicer, quite frankly, and I haven't had any issues with it since they fixed all the issues with NVIDIA and all that stuff, so it's been great. Used to have 3 monitors where 2 were standard stacked on top of each other, and then the third one was vertical for programming. That setup was nice. Then my cat decided to knock them over, so now I just use a big TV. Oof. That's painful. It's funny you mentioned using a big TV, because when I was in college, the only monitor that I had at one point was a 40-inch TV, but it wasn't a 4K TV, because this was in college, so this was a while ago. It was a 1080p TV, but 40 freaking inches, right? Great for doing artwork, terrible for programming on. You just had an Airheads ad? I didn't even know Airheads were still around. I thought those went away in the late 2000s, or early 2000s rather. Late 90s, early 2000s. I haven't seen one of those in ages. I know what you're talking about. I used to love those things when I was a kid, for sure. All right. So obtaining a unique ID. So I think probably the best way to do this is going to be, I think we said all IDs are going to be U16, so we're going to have, I think we're going to do two functions for this. Is probably going to be one for the base asset, and then one for the instance of one of those base assets, right? So we'll do get base ID, and we'll do struct k animated mesh system state, and actually, I guess what we could do is we could also have the simultaneous lookup of kname asset name. And what we can essentially do is do a, let's see, states base meshes. Yeah, we're going to want to do a U32 length equals D array length of states base meshes, and then loop through that. So U32 I equals 0, I is less than length plus I. And then we'll do if, state base meshes sub I asset name. Actually, we should probably compare both asset name and package name, because we could technically have the same asset name come from different packages. Yeah, let's do that. Let's do both. Kname, package name. So we'll do and state. You know what? I hate indexing that many times. What is this? I think this is just a K animated mesh asset. So let's just where did I go? Okay. Interesting. Okay. I just found a accidental key combination that moves me around in a way that I didn't realize it moved me around in Vim. Anyway, so we want k animated mesh asset, and we're going to do base equals. We'll take the address of state base meshes sub I. That way we could just do base asset name equals asset name and base package name equals package name, right? So if we have a match there, then what we're going to do is we're just going to return I, right? And that is going to give us sort of our base ID. So if we already have one that exists, whether or not it's loaded doesn't really matter at this point. But if we already have one that exists, then we're going to go ahead and just use that. If we don't, then we're going to need to, if one does not exist, create a new one. And this is a sort of two-step thing, right? So first look for an empty slot. If no empty slot, push new entry and use it, right? So it's sort of a multi-step thing there. They'll probably disappear after the food color ban, to be honest. Yeah, or they'll just be really boring colors. You just keep seeing David Beckham really enjoying headphones. That's funny. The range of ads that you get is kind of hilarious to me. Like I've had some of our Brazilian viewers have told me that they get ads in French, which is deeply funny to me. Because like, who decides that, right? Half the reason I'm subscribed to this channel is because I really like the content. I appreciate that. The other half is because I don't have to have ads. I appreciate that. I really do appreciate the support, by the way, Apotham. Big time. So, yeah, just another thank you for that. What's that dream to have a dream? Yeah. What's the game, by the way? And do you want that to be a pre-increment? Okay, so the game itself, I'll just answer that really quickly. So the game itself is going to be a 3D sort of isometric perspective action RPG. And so we've done a little bit of design. We've had a few streams where we did a little bit of design, just kind of coming up with some basic ideas behind the game. The game is called Shadows of Illumina. And every reference that you see in here to Illumina is actually referencing the game. And so Kohi is a reference to the engine. Illumina is a reference to the game. And so the game is basically our test driver for the engine. So as we develop the game, we're going to be going back and forth between working on the engine, fixing things in the engine as we find them, and going back to the game code. So we're doing those in tandem. At least right now, we've mostly been on the engine, which is the way it's going to be at the beginning. But eventually, as we fill out all of the engine features that we need, there'll be less and less of that, and we'll spend more time in the game. Do I want it to be a pre-increment there? Yes, I do. I usually use pre-increments. This is sort of an old school habit of when this wasn't always necessarily something that the compiler optimized for you automatically, because this can actually translate into one instruction instead of two when it's actually compiled. Most compilers these days actually optimize that automatically now, but some old habits die hard, I guess. So in the case of a for loop, it literally does not matter, right? Because this all gets executed before this gets incremented. So whether you do a pre-increment or a post doesn't matter here. Key combination I do not like in Vim is Control U, how that deletes a line. My LSP is Control Y. And I can't tell you how many times I've deleted the line I'm typing instead of accepting. So something that I do, like, I used to get really annoyed because I hit escape a lot, but I would also, like, on occasion hit F1. And so I essentially remapped the F1 key to do nothing. So like for annoying key combinations, like usually what I'll do is I'll just go into my Vim config and just map that to nothing. That way it just stops doing the annoying thing, you know? Or sometimes like I'll go to like do write all like that, but like because of the way that I type, sometimes my pinky finger hasn't lifted off the shift key, and sometimes I'll do that. And so I just actually mapped that to the lowercase version of it too. So I just kind of do things like that on occasion in my Vim config just to get rid of some of those annoying things. I probably will wind up doing that with a key combination I just found. Not complaining about the ads, they're reasonable and short. Been on some channels that say 1 of 9 ads and I bounce. Yeah, so I don't have like a lot of them playing. You can't not have any of them because Twitch has got to make their money, right? But yeah, I chose for like a balanced experience as best as I could. Because yeah, ad revenue doesn't really pay a whole lot in terms of, you know, how it works out on Twitch, but it is what it is. It certainly doesn't pay out enough to make it worth having 9 ads in a row. I mean, maybe that's true when you have, you know, 100,000 followers or something like that, but certainly not for anything at this scale. Okay, so here we're going to look for an empty slot. So we're going to, again, I'm actually just going to take this and we're going to repeat it, right? So the way that we're going to have, or that we're going to designate an empty slot is we're going to say that the asset name needs to be, is it invalid K-name? I forget. Yeah, invalid K-name. In other words, it's not named. And in that case, we can actually use that, right?
Pot friend.
Ilis42, thank you so much for the sub. 8 months. I really appreciate that support. Thank you so much. That means a lot. And thank you guys for the follows also. I really appreciate that. Yeah, that definitely helps me out. So, and any little bit helps, I really appreciate it. It's pretty interesting to see someone using C over C++ or C# in game at dev, to be honest. Recently started working with a lot of C in my work, and it's been nice. Yeah, I really like working in C. I prefer it over either of those two. I've done enough C++ to know that I don't want to use it. There's only a couple features that I miss from it. And those really aren't all that big a feature, right? So it would be operator overloads for like math functions, specifically for like vector math. I miss those a little bit on occasion. And then constant expression to be able to have, you know, compile time logic, right? But like other than that, and maybe function overloads for things like logging, but even that is like minuscule to me. I didn't really use anything else, so I just used C. All right, so this is considered a free slot. So we'll say use it. And then if we don't have an empty slot, then our last resort is to push a new one. So what we're going to do here is we'll do a K animated mesh asset, and we're just going to say dummy. And then we'll do darray. Oops, that's not a push. There we go. And I want state base meshes, and in that I'm going to push dummy, right? And then I can return U16 , right? And I can use length because whenever we push, it's always going to be at the very end of the array. So length will technically be the index of the last element that we would have just added, right? So that makes that pretty straightforward. And that's all we need to do to get a base ID. Now, what we probably should do is there are two cases here where it did not already exist. And we probably ought to fill out, the asset name and package name. So I think actually rather than returning here, I think what I'm going to do is let's do this. We'll do U16 index, or I guess we'll say ID equals invalid ID U16, right? And then we'll do, instead of a return here, we'll simply do a ID equals that, and then break. And then down here, we'll say if ID equals invalid ID U16, then we'll go ahead and do this. And then instead of returning, again, we'll just say ID equals that, right? And then at this point down here, we can go ahead and set a few things. So we can do, we can then come here, and we can just do new, we'll call it new underscore base, if I can quit hitting the wrong freaking keys. And we'll do ID, right? And then we'll do new base, asset name equals asset name, and then new base package name equals package name, right? And that will ensure that our future lookups will actually, I should say, whenever we go to execute this in the future, that will make sure that that slot is reserved, right? So now we can just say return ID. Now, there is something that I just thought of, though, that might be a little bit, Now that I'm thinking about this, we should probably have a state separate from the actual asset. Because our asset system is not going to quite work that way. So if we take a look at our asset system and how some of the other assets work, let's see. These usually return a pointer to an asset. So we probably ought to rethink how we actually do this a little bit. And I probably ought to rename this to be a little bit more consistent with the way that the rest of these assets work. I hadn't thought about that yet. We're not too far off. So we have we essentially have all of these different assets, which are different structure types, right? This is what a material asset looks like. This is what a text asset looks like, a binary asset, a KSIN asset, et cetera, et cetera, et cetera, right? We probably ought to... I had forgotten that we actually defined all the asset types here. We are actually going to have to move... Oops. We're going to have to move this definition of this asset over here. Which means I'm going to need a lot of these other types to go along with it, which I don't know that I necessarily want to do. So maybe we should tackle this in a slightly different way, where we talk about, instead of this being an asset, we don't think of this as an asset. We think of this as sort of the base animated mesh, which is what we're kind of referring to it and calling it anyways. So maybe we just do base, right? We'll say animated mesh, K animated mesh base. Wow, that did not work. Okay, cool. I'll do it the hard way then. Ya dangus. Base. I think this is going to wind up changing anyways. Look up by index. We'll come back to that. Yeah, I think instead of saying this is an asset, right, this should probably be a base. And then the asset itself should probably be a slightly different structure that we can then turn into this, right? So if we think about an animation, a lot of these types are fairly simple types, right? They're basic types. But then we also have the channel, which has a list of these things. So these types are better for our animation system, but aren't really good for deserializing out of like a binary format. Now that I think about it. So we probably ought to rethink about that just a little bit. So type def struct k assets, and we're going to do animated mesh. And I guess we can kind of just go backwards with this, right? You think about it. Okay, so we don't have to keep asset and package name on the asset. We're not doing that anywhere else, so that is fine. That doesn't really matter. We'll only need to do that like if we have hot reloading support, which I'm never going to do for animated meshes. So animated mesh animation. I guess let's look at animated mesh animation first. That has channels. Channels have all of the keys. So I'm going to slightly duplicate some structs here, but not completely. Right, so what we're going to do here is we're going to make this a little bit more friendly for serialization, so that when we go to actually store that in a binary file format, which we still have to define, it'll be a lot easier to pull the data out. So each one of these channels will have a name. That isn't going to change. U32 position counts, that's not going to change. However, we have this anim key vec3 positions, each of which contains a vector3 value and a time. I think for the since it's all float types that we're dealing with, well, I was going to say I could use a vector4 to store it, which would make it really easy to deserialize, but that's not going to work for quaternions. So maybe I do have some sort of... I could either make two arrays or two structures, is the way I could go with it. One or the other. Operator overloading is nice, but way too many times have I seen done things that are way too creative with it. I agree. Yeah, it gets abused. 100%. Thinking of writing my own math library because the one I'm using is not to my liking. Yeah, that's fair enough, Apotham. I get that. I mean, we wrote our own for kind of similar reasons. Also, I guess, educational reasons, but yeah. Vivek over on the YouTube side is saying, "Sir, what is this?" We are doing engine development. Specifically, we are scaffolding an animation system. So we're thinking about the structure of what a animated mesh asset will look like, as opposed to its state when it's actually loaded and stored in our animation system. So we're kind of laying out the data for that. We already have a lot of the code in the animation system done. It's just a matter of translating from an asset format, which we haven't yet defined, to that internal state. So that's kind of what we're trying to figure out right now. I guess I feel like a structure is still a little bit cleaner here. So I'm actually going to do a type def struct k asset animated mesh. Instead of channel, we're going to do key vec3 3. Okay, so this will obviously, just like the type over to the left, will be a vector3 value and a f32 time. And then we have the same thing that we're going to need for a quat to store rotations. So we'll do that. I can spell. And so we'll use the vec3 for position and scale, and then the quat for rotation. So k asset animated mesh key vec3. That's going to be positions. So I realize the types are the same now, but they might change and diverge, is what I'm thinking. Depending on, especially when we go to add more information to the format. So we'll have that. We'll do I guess we'll do scale next, and we'll do k asset animated mesh key vec3 scales. Yo, it's T3K. Thank you so much for the supporter 2 over on YouTube. I appreciate that very much. Thank you very much. I appreciate the membership there. I appreciate the support. Thank you very much for that. That means a lot. I really do appreciate it. And welcome. So your name will actually show up on the credits in the next stream then. Okay, so we have rotation count. I'm just going to call this rot count. And k asset animated key quat. And that's going to be an array of rotations. Thank you. Been learning a lot. I appreciate that. And I'm glad that this is proving useful to you. That's the whole point of me doing it. So why is my cat screaming at me? You know what? Since you want attention, let me change my camera here so you guys can see my kitty. Let's see, this one. Here we go. She wanted my attention, now she has it. There's my kitty. She just decides that every once in a while she hears me talking and she just wants attention, so. Now she's decided she wants to go. She's a about 15-year-old Japanese bobtail, for those of you who are curious. Just got to find him enough sponsors that he can full-time this game and engine. I know, right? Yeah, I mean, that's the dream, right? But, like, I'm a long ways off from that. I'm probably at, like, 4% of where I'd need to be to actually pull that off. Okay. So, let's see. This is each channel. So we have that. Okay. And so the channels are contained in an animation. So we can do type def struct k asset animated mesh animation. Animated mesh animation. Right? And so this is actually going to contain these same properties. Minus, or I guess differentiated by k-asset animated mesh channel array of channels. So we have that. Let's see. We are going to need the nodes, the bones, and then some of these other things here. So again, a lot of these are going to be like straight one-to-one copies, but I suspect these two formats or these two sets of structures are going to diverge at some point. So we'll do a... we're going to need a couple... Actually, you know what? Let's just copy pasta these, and I'm just going to rename them over here. So this is going to be... k-animated mesh. Oh, you know what? This needs to be k-animated mesh asset. Is where all this stuff should be. Oh wait. No, it should just have k-asset. Did I do that already? I did that already across the board. Okay, so it's just these. Yeah, it should just need to do this, essentially. And then k-geometry. K-geometry we're not currently using here. And I don't necessarily need the whole k-geometry structure for this, actually. Because the asset doesn't know anything about generation. It doesn't know anything about vertex buffer offset or index buffer offset. And we actually know the type of the indices, so we don't actually need this. Same with the vertices. So we are actually going to wind up splitting those up and treating them a little bit differently. And material is actually going to be name, and this is going to be material name, right? So the asset isn't obviously going to store a material, it's going to store the name of a material. So we're going to have all of our animated meshes are going to be skinned vertex 3Ds, right? So that's going to be vertices. And we'll do U32 vertex count. And then we're going to do a U32 index count, and we'll have U32 indices, right? So that's how we're going to represent the mesh, which, like I said, is a little bit different from this. So that's one way that they're going to diverge already. That and the obviously the material name. Which actually, as far as assets go, technically speaking, we're not going to store this as a k-name. We're actually going to store this as a string in the asset. So that's another way that they're going to diverge, because we can't actually use k-names at this level. I mean, I suppose we could, but we would have to know to decode that when we're reading in the asset. Do I want to mess with that? I think all the rest of the assets do use them though. So I guess we are kind of being intelligent about that when we actually load. All right, I'll leave it. Okay. animated mesh. Ooh, that's an interesting bit. So within an animated mesh, technically we have multiple submeshes, right? So this is actually going to be, I guess we'll call it submesh data. Because we can have more than one of these, right? And we can also have, bones that go to multiple meshes as well. So technically speaking, we're actually going to use most of this stuff. So I'm actually going to copy pasta this over and change the relevant bits. So this is the actual I guess we'll call wrapper for the entire animated mesh asset, right? So this contains, instead of k animated mesh, we're going to say k asset animated mesh subdata. And we're going to call this sub meshes, right? So we have we have sub mesh counts. That can stay the same. The k animated mesh node is going to wind up being the k asset animated mesh node. Same is going to be true for those. Okay, so when we deserialize from the binary asset, this is what we're going to wind up with, is this structure right here. And it's going to have an array of animations, an array of bones, and an array of nodes, right, to give us that sort of hierarchy. It'll also contain the asset name and package name, which actually I don't think we need to do. We don't need to store that as part of the actual asset. So it's actually just going to contain all of the submesh data as well. So this is like all the animation data. Whoops. So everything from here is all used for animations. Everything from here down is the actual geometry. And so when we deserialize that or import from using assemp or whatever, this is what we're essentially targeting in binary form on disk. So we have that, which means that when we go to create or load an asset, we're going to load one of these on disk, and we're going to translate that into one of these, and then we can release this. Just trying to think if there's any holes in this logic. I don't think there are. I think this is the way we should do it. And like I said, I know that these types are very similar, but they are not exactly the same, right? And I think I'm fine with that. Let me also do my due diligence here. If we need a string form of this, we'll do kasset type name, and we're going to say animated mesh. And we'll do animated mesh. So we'll have that. And I guess we can actually just do this down here as well. And then just move this here. Okay. And this is going to be a Kohi animated mesh asset. Okay, I think we have that sorted. So we are going to have to tie this into our asset system as well, which means we're also going to have to define the format that we want to load. Which means that we're also going to need a way to serialize and deserialize that. So we've got those bits to write too. I think what I might do is in the asset system, I think I'm going to define the interface points for this so that we at least have functions to call. And then And then from there, we'll just go ahead and call those things, and we'll just leave it full of to-dos, right? We did have this skin mesh assets. I'm going to take this out. I guess we could kind of replace this. We do have skin mesh. We did have skin mesh geometry, which is kind of the same thing, but these are going to go away because we don't have that separation between skin meshes and skeletal animations anymore. It's all the same thing. So we can come in here and we'll do animated mesh assets, and we'll essentially change everything in here that says skinned. We'll change all of that to animated, right? So that's going to be essentially I could just do a blind find and replace on this, but I actually want to see every instance of what I'm changing. And I just realized I'm probably coding behind my head here, so let me scroll that up a little bit so you guys can actually see it. Mostly just doing find and replaces, so that's not really a huge deal. Oh, I had a skin mesh serializer. Did I actually define that? I did define it. Okay. I'm gonna have to do redo that one. Okay. So we'll come back to that. All right, so we have a callback here. This is probably going to wind up being in the header file, if I had to guess. So this is going to wind up being a few find and replaces here as well. Okay. And then this is going to be animated mesh assets. Okay. So we have that. And then I think all that's left is probably the deserializers and any differences in data structure that we have. Yeah. Mostly around cleanup. And some deserialize and serialize calls. Okay. So I guess we could tackle the cleanup first, because that seems like a decent place to start. So for this, we're going to do, I guess we could do submeshes and submesh count. And then this is going to be submesh count and submeshes. So that's going to be k-asset animated mesh submesh data. Okay, so we free the vertices. Let's see. Size of, okay, so we just use the size of the first element of that. So that's fine. This is going to be submeshes, and then submesh count. So that's going to be largely the same no matter what we do there. And then if assets, we probably got to do animations. And assets animation count. Then essentially we're going to do the same thing. So it's going to be for U32 I equals 0, I is less than asset animation counts plus I. And then down here, of course, we'll have the, and it actually, instead of, I'm going to do K free type C array, which is something that we didn't have when we wrote this initially. So now we can just specify, we could say asset animations, and then we can specify the type, so K asset animation mesh animation. Right? And then the count is going to be asset animation count. So we just free that array. But for each one of these animations, I think we have asset animations sub I. Let's see, we do have channels that we need to delete out of there, which I don't think the channels, did the channels themselves? Yeah, the channels themselves have arrays in them. So we are going to have to do another small loop in here, which kind of sucks, right? But it is what it is. So we're just going to iterate through asset animations sub I channel counts. And this is going to be one of the few times you're going to see me use C++ on this channel. Right there. Everyone needs a keyboard cat? Yes. I agree. She does not actually like being on my desk, though, or my lap, at least when I'm working. But she does want attention sometimes, and she hears me talking. She'll come and be like, I want pets and I want them now. So yeah, she's like a cat version of J.G. Wentworth, essentially. But yeah, I mean, she's still circling my feet at the moment. Okay, so for each one of these things, we're gonna do I feel like we should. I should probably also grab we'll do a channel, right? And we'll call this CH, and we'll take the address of asset animations sub I channels sub C. And we'll do if we'll do if CH position count, and actually yeah, I should probably check this first. CH positions. And then we can do K free type C array, CH positions. And then this is going to be K asset animated mesh key vec3, and the count is going to be CH pos count. Right, and then we could just do the same thing. You can do the same thing for scales. So scale counts. So scale counts, scales, scales. Jeez, keep hitting the wrong keys. Scales. And then for this one, it's going to be rotation counts and rotations. And this is going to be rotations, and then the type for this is just going to be changed to quat. Why is that bleating? Unsigned long. Channel rotations is, oh, this should be rotation count. That's why. Okay, Oh, I was coding behind my head again. Sorry about that. So all I did through here is just basically free those arrays for that channel, right? So we do that for every channel, and then I'm actually just going to grab this, and we can, once we've gone through all of the channels, we can free the channels array as well. So we can do asset animations sub-I channels. And then this is going to be channel, and then asset animations sub-I channel count. All right. So we've got that. So each animation has its array of channels, which then have the rotation, scale, and position keys in them that we need to free. That should do it for animations. And then there's just the matter of, I think everything else is flat. So asset, not the submesh. Well, we already got the submeshes, so actually I might have been right about that. Let's see. So I guess bones. Because nothing in here contains an arrayed type that we have to free. So all we'll do here is we'll just do a k free type C array. Again, it's going to be asset bones, k asset animated mesh bone, and then that's going to be asset bone count. All right, so we're going to do that same thing for, nodes. So node count, or nodes and node counts. It doesn't really matter the order we check them in. This is going to be nodes. This needs to be changed to node, and then this needs to be changed to node counts. All right, now, the reason that we are not zeroing any of this out is because once we're done, we are going to zero out. I guess we're actually freeing the entire thing. So, yeah, there's no need to necessarily zero it out because we're going to free the entire block of memory anyways. So that's that. That's releasing an animated mesh. Simple enough, I think. And then all we need to do is the matter of serialization and deserialization, which we do not have yet. But we did have a skinned mesh serializer. So that's, I'm trying to think, where did we put those? Serializers under core. Okay. So we are going to rename this one to animated mesh serializer, and we're going to rename this one as well to animated mesh serializer. And then we'll just go through here and do a quick find and replace. And we'll do the same thing over here. And what I'm going to do for now is I'm actually just going to essentially go through here and just blind find and replace a lot of these things, with the exception of that one. And we'll come back and all right, I'll have to come back and fix that. we'll come back and fix a lot of these types after the fact. Once we actually get ready to define our format, I just want to have sort of the usage code figured out first, and then we can come back and actually sort out the details. Okay. So the last thing is this asset type, which we can go in here and change. This is going to be animated mesh. So that's going to be animated mesh there and animated mesh there. Okay. The rest of this I'm not going to worry about just yet. I could probably do most of this offline once I think about, either offline or on the next stream. Once I have a chance to think about how we actually want to store this on disk, right? So this is basically literally the serialization process to get it into a binary format. So we have a deserializer and a serializer, both of which we'll need to use. We'll need to use the serializer for the import process and then the deserializer to actually load it in the engine. So we've got that. I'm going to leave the rest of that for now. Okay, and I think that actually sorts out our asset system, which is good. So now in our animation system, we actually just want to use, instead of k-animated mesh asset, we're going to use k-asset animated mesh. And this is going to be, well, okay, so we have asset type. Wait a minute, though. I don't think I actually want to use that directly. Nice, my cat just threw up behind my chair. And is currently throwing up underneath my chair. I will be right back. I've got to clean that up. Sorry, guys. All right, I'm back. Sorry about that. Okay, so what program is this? This is NeoVim that I'm coding in. Dr. Elliott, good to see you. Welcome. Hope you're doing well. Used to use that C++ joke all the time when I was making a game engine with my friend. Used to refuse to accept my code submissions when it was in there. That's hilarious. Is that because it contained C++, so it wasn't allowed? Oh shoot, am I muted? Can you guys actually hear me? Because OBS doesn't say I'm muted. Not muted, okay. Okay, I thought it was me for a second. I was like, my OBS says I'm good, but okay, cool. And you can hear me over on YouTube. All right, perfect. Thank you for the confirmation over there. Appreciate that. Okay. So, working on an entity picker with a small RU32 uint texture. Oh, are you doing essentially color picking, Dr. Elliott? I've done that before. Actually, on stream, we've done that here. It's kind of a fun exercise. Yeah, it's pixel perfect picking. Okay. So my initial thought behind this is that, like, we use the base meshes directly, right? Or the base asset, right? But now I'm actually kind of thinking. Now I'm kind of thinking like I'm leaning more towards like we shouldn't maybe do that. We should use K animated mesh base, right? Which instead of, well, I guess this really isn't the asset anymore. I guess this is fine, actually. I guess we don't really need to worry about that. That should be fine. What's the warning that it's bleating about in here? Oh, resource types? Yeah, we don't need that anymore. Okay. So now that we have separation in types, we don't actually have to load the asset from disk and like keep that around in memory. So when we actually load that up, we can just copy what we need out of it and then throw it away, which is good. So that is essentially what this acquire from package is going to do. Let me have a few things in here I'm going to have to fix as well. Let's see, K animated mesh. I think I just called this base, right? Yeah. So there's just that I've got to fix in a few different spots. No big deal. Okay. Oops. One more right there. Okay, cool. So we do actually have the word asset mentioned in here a few times. I'm actually just going to close this other buffer for a second. So I guess we can go by this. That should be fine. Where else? I know I saw that in a couple of other places. Okay, so we were calling this asset. We should probably rename this, right? So this should be find node index. Let's rename this to anim. I guess let's do, we just do base find node index and then rename this to space. Same thing here. So we can actually just rename this to base and then rename this to base, just so that we're not getting confused about sort of the way that we're naming things in here. The animator also, the structure for the animator is referring to this base as an asset. That is no longer the case. That is just now a base. And like I said, we probably should look this up by index anyways. In fact, let's actually just do that now.
You dingus.
So we'll do a U16 base, right? Index of the base mesh. Thank you for the follow. I appreciate that. He was a big C++ oop guy and hated whenever I would make fun of C++. That's funny. I mean, I'm a proponent of like use whatever you like, right? When I make fun of stuff here, it's very lighthearted. I'm not actually being serious about it. But yeah, some people take that stuff very seriously. So yeah, that's a thing. Okay, so we are going to now get this from the address of, actually we'll just say the address of assets, well, not assets, right, we don't have the state here, do we? You undo that for a second. We actually need the state. Or I guess instead of doing it this way, we could theoretically just pass the base, right? We could just pass that. Maybe we do that. Let's do, so let's see, we want to process, we want to process the animator using a, I'm going to pass state and look it up that way. I think that makes the most sense. Right, we'll do that. We'll do the address of state base meshes sub animator base. Right, we're not keeping a bunch of pointers to things, but we can still look them up. Okay, so this is just going to pass state. And then animator creates, let's see, assets. When we create the animator, we need, let me think about this for a second. Do we actually store? We don't actually store it. I suppose we could. Right, we could actually store ID in there, and that would actually be better than going off the name, right? So we could do base equals asset.id. And then in here, base would actually be it's a little more annoying to have to look it up this way, I guess. But it's not really that big of a deal. Wait a minute, that seems like the wrong one. Yeah, it was. That's the one I want. I really need to delete that other system out of here. So this is going to be animator base, which is now a U16. So let's do K animated mesh base equals address of state base message sub animator base.
You dingus.
Right, and then we could just do that. Thank you for the follow. Appreciate that. Are we making game engine? Yes, we are. Increase the font size a little bit. I maybe could increase it a little bit more. The problem is going to be like I'm going to have problems with like fitting text on the screen. So is that maybe a little bit better? I don't want to make it too big because then I can't fit too much on the screen. But hopefully that's, if that's a little bit better, just let me know. Oh, your PC wasn't outputting any sound? Yeah, I've had that happen once or twice. It is better? Okay, cool. All right, so animator current animation. So this is another thing I said I wanted to have work by index. So instead of keeping a pointer to this, we're going to have U16 current animation, right? And so this is the index into the animations array. And then actually what we'll do is we'll say invalid ID U16 equals no current animation, which is kind of a standard thing that we do anyways. So we have an index here. This is using a U32. I'm going to switch that to U16 because we're not going to have that many animations. In fact, I could probably even use a U8 there and be fine. So all this actually really needs is that. Simple enough. All right, animator updates. So this is current animations. We're gonna have to look up animations within the let's see, within the base. So we're gonna have to get a reference to the base, which is gonna be this. Also, this needs to be changed from just a simple not to invalid ID U16. And then we also need the state here, K animated mesh system state. Right, so now we can actually say current animation. So K animated animation equals the address of base animations sub. Let me think about this for a second. Animator current animation, right? And now we can just say current for all of that, right? So we can just do this. Same goes for all of this. Let's see. So process the hierarchy. This too is going to need, oh, it already is passing the state. Perfect. Okay, so we already did that. So we passed just a pointer to the animation there. I think that's actually fine. Here we can just pass, we just pass current there. And then this is just going to be base. Yeah, okay. I like that a little bit better. And then, of course, we have, we're going to need the base again for down here. So we just do base there. And then we obviously need state here. So we can get that. And then let's see, current animation. Okay. So when we create an animator, we're essentially setting the default animation here to the first animation if we have any animations at all. If we don't, then we essentially need to set it to invalid ID U16. But instead of setting to a pointer here, we just want to set it to the actual index of 0, right? Because this is just a index now. Okay. That looks pretty good. Let's see, what other warnings do we have? Just lack of return types. Okay. So that's pretty good. Okay, so at least now when we talk about getting our base ID, there's one more thing that we need to do. So we have new base here. We need to set the ID equal to ID, right? And that's another thing that we can use. Instead of using asset name and package name to determine what's free, in fact, we can use that for the lookup here to see if we already have an existing one. Right, so we can search for currently loaded existing assets for a match first. Right, so we try that first, so we will need the asset name and package name for that. However, when we're looking for an empty slot, we're now going to do ID is invalid ID U16, right? Okay, so if the ID is that, then we know it's a free slot. We can use it, and then we break. If we didn't find one, then we create a new one and go with that. And then we set the asset name, package name, and ID here. So that's get base ID. Get base ID completes this first step, right? So we have, in fact, let me just move this down here. So here we have U16 base equals get base ID. We want state, and then asset name, and then package name, right? Now, if actually, I don't think there's any scenario where this should return invalid ID. So we should be safe to always say that whatever we have here is valid, right? So what we're going to have down here at the bottom is we're going to return K animated mesh instance, right? And the first thing is going to be base mesh equals base, and then instance equals invalid ID, right? And this is going to be a to-do. Fix me, actually. Use actual instance ID, right? So that is what is going to be returned. Okay, so the first step is complete. The next thing we're going to need to do is, let's see, check first to see if a name with that exists. Okay, so we should probably actually we need one more piece of information from this. So when we look this up, we need to say, did this previously exist or not? So instead of returning this, we're going to do a Boolean there, and we're going to do a U16 pointer out ID instead, right? And then this is going to be returns true if already exists, otherwise false, right? So this is actually going to do out ID equals that, return true. And then we'll do out ID equals ID, oops, return false. Oh, thank you so much for the gifted sub. I appreciate that. Yeah, thank you very much, Paul Newman. I appreciate that very much. You gifted a sub to Cursive. So Cursive, if you happen to be online, definitely give a shout out to Paul Newman. I appreciate that. Let's see. I don't know how to pronounce your name. I guess is it Thy Arc? First time chatter, welcome. New, just graduated. I'm here for wisdom. Are you okay? Can I ask some doubts? Well, that depends on what they are, but feel free to ask away. Yeah, Paul Newman, I really appreciate that. First time chatter, by the way. Thank you very much for that support. I appreciate that a lot. Thank you for the sub over on the YouTube side as well. I do appreciate that as well. Okay. So yeah, this makes a lot more sense here. So now when we do this, I can set this to invalid ID U16, and then we can do B8 exists is equal to that, and then we can pass the address of base, right? And then if not exists, we can do to do kick off async asset load via the asset system, right? And then if it, let's see, I think the only other thing is to, we need to, I'm actually going to move this up here. Okay, so we're getting ready to do that. In fact, we already kind of have that. We just need to create a instance, right? That's the only other thing we have to do, and we have to do that regardless of whether or not it existed. So the base may or may not have been created. This asynchronous loading process just needs to be kicked off. We don't care at this point whether or not it's actually finished loading by the time we get here. All of that stuff is irrelevant until we get ready to draw it. So let's see, I got a couple minutes here. I think I can probably go ahead and write that. There is one more thing that I forgot to do though. So for this, we actually need to push a new, also push a new entry into the instance array for this base, right? So what that basically means is we need to do a k-animated mesh instance, and we're going to do new inst. And it doesn't really matter what data we put here for now. What really matters is that we do a darray push, and that's going to be to state instances new inst, right? And actually, I don't know, is that, I don't think that's right. I think what I actually need is I need a new array to be pushed here. So this is going to be new inst, new inst array, right? So this is actually going to be darray create k-animated mesh instance. And then we push that array into the instances array, right? That way we can start creating new instances at the same index in this array as this array. Then we'll have what we need. Thank you for the follows. I appreciate those. Thank you very much. All right, so creating a new instance. Let's see, what all do we have to do for that? Wait, I don't want to use, no, that's not the right structure. I want to use the animator for that. This. That's what we want, right? Because the instances are animators. Okay. Actually surprised this didn't catch that. Okay, so let's do I think we can do a return type void on this one. Let's make it static. And we're going to do get new instance ID. And what we're going to want is we're going to want U16 base ID. Do we need anything else? I don't think we do. We are going to need the instance ID to be returned, so that's going to be U16. Right? So the way that this is going to work is we are going to get the base as we have other times before. So actually, we're going to need the state. We are going to need that first. And then we'll need that. It's just easier to copy it sometimes. Instead of sub I, we have base ID. And then from here, we'll do base Actually, do I even need that? I don't know if I actually need that. D-array push. It's going to be state instances sub base ID, which will give me the correct instance to push into. And then we want new inst, right? So that's what we have to do if one doesn't exist. And then we need to do U32. I guess I could probably just use this U16 for this. Length equals D-array length. And we can actually do state instances sub base ID here. And then for U16 I equals 0, I is less than length plus I. If state instances sub base ID sub I. Let's see. I guess we could use base ID for this, and we'll say this, if this is invalid ID U16, free slot found, use it. So we could just do state instances base ID sub I base equals base ID, and then return I. So if we find an existing slot, we can go ahead and use it. Otherwise, we need to push a new one. So we can actually do new inst base equals base ID here as well. And then that gets pushed into there, and then we can return length, right? So if one exists, we use it. If not, we push a new one in there, and that gives us our instance ID. So all we have to do here is actually, I don't think we're going to need it beyond this. So actually, I think we can just do get new instance ID, state, and then base. And there we go. So the only thing that we have to do now is just kick off the asset async load, set up the function pointer for that. And then once we have the callback set up for that, we'll upload all the verts and indices to the GPU, all that stuff. Request material instances, all those good things. And that'll be sort of the next step. Let me see. So I'm going to read just some comments really quickly, and then it's actually time for me to end the stream because I do have work early in the morning. Hyman Cordoso, another Brazilian viewer. Welcome. We have quite a few of you guys here. Glad to have you here. So if I plan to make a C++ physics engine, right now currently doing it to make it as part of a portfolio, I'm not focusing on the rendering part, so I'm using Raylib for now. Question is, almost all my programming is written in CPP, but is it okay to include Raylib H and renderer using that? Is it good practice? I like mixing C++ main program with C libraries. Yeah, so I mean, you can always use C libraries with C++. There's nothing wrong with doing that. You know, people do it all the time, especially like the Vulkan SDK and things like that. They do have C++ bindings, but the C ones are a little bit better, in my opinion, and of the opinion of a lot of others. So yeah, mixing those is fine. I don't see an issue with that. Yeah, I wouldn't worry about it too much. There's nothing wrong with doing that at all. All right, so like I said, this is where I'm going to have to end the stream for tonight. I'm going to find somebody to raid. I think I see who I'm going to follow, actually. Yes, I know exactly who I'm going to follow. Because he hasn't actually been on when I've been streaming for a bit. So we are going to raid Kuju, who's writing a pretty awesome looking game called Fat Goblins, and he's using Jai to write it. So super interesting project. We are going to go and see what's up with him. And yeah, thank you guys so much for being here. If you haven't already, I would really appreciate a follow, either on the Twitch side or the YouTube side, or if you're so inclined, both. It helps me grow the channel, and I really greatly appreciate it. Again, I want to say thank you to all the folks that gave me some support here tonight. I really do appreciate that as well. Thank you guys. And yeah, we will see you guys next time. Have a good one. See ya.